last minutes to think for you then. I promised to give you a video on the cosine rule, sine rule, arcs and sectors and things like that. Let's just pick up on a couple of things from here. We did most of these today, okay, all of these number things we covered today. Just in case these two are linked, we did some questions today, which was like, what are rational, what are irrational numbers? Just in case it's linked to indices, say we had, I don't know, something like that, right? You could just put it in your calculator in this paper. You don't, right? Unlike in paper one, where you have to know rules, you could just put that the index in your calculator, and it will tell you that this is the square root of 16, which is 4, and the minus is 1 over, so it's 1 over 4. But then show an awareness that that is rational. Anything that can be written as a number or a fraction is rational, okay? Whereas something like 17 to the power half, not even negative, which is the square root of 17, that is irrational. So what numbers are irrational? As far as we are concerned, or we need to know for now, pi is irrational, pi squared is still irrational, so is pi cubed, or pi to the power 4. Pi to the power 4, it's not easy to say, is it? Also, square roots without answers are irrational, surds in other words. Cube roots without answers are irrational. Fourth roots without powers are irrational, or anything like that, okay? We've seen questions before, like give two rational numbers that will give two irrational numbers that will times to give a rational answer. So that's irrational because it doesn't have an answer. That's irrational because it doesn't have an answer. But when you times them and get that, the answer is 4, which is rational. So two irrationals making a rational answer. Okay, did a lot of the algebra today. One thing I didn't cover today was the non-linear graphs, which is in one of the booklets, 135, can't remember. I have to have a look back through it. So a knowledge of what graphs look like quadratic graphs, cubic graphs, reciprocals like y equals 1 over x, looks like that, or linear graphs, etc. You need to have a look at that yourselves. Changing the subject of the formula might be its own question, or might just be locked up in another question, an ability to move things around, okay? Could be even in a sine or cosine question, because we have to rearrange the formula, could, okay? As far as I'm concerned, quadratic expressions and equations here probably mean solving a quadratic using the formula. So it will say solve to so it'll say something like solve this quadratic to 2 decimal places, which means don't try and factorize it here. Solve it with a quadratic formula, copy it from the front, and you're away to go. Algebraic fractions, again, these two could be linked, because it's possible to have algebraic fractions where you have to simplify them. We did a couple today where there's a quadratic on top and something on the bottom, and they need to be factorized in order to simplify them. Okay, we did a few of that today. What else we got? Pythag, trig, metric units, just again, will probably crop up in our volume, right? So again, these 4 potentially kind of are a little block of things. Density, which is density, mass, volume, DMV, learn it in that order, apply it correctly. Okay, perimeter and area of shapes, surface area, volume, okay, just things to be aware of. They could crop up together. And knowledge that, like we said today, that if you wanted to change centimeters cubed into liters, you would divide by 1,000. If you want to change centimeters cubed into meters cubed, weirdly, you would divide by 1,000,000. It's a nice one, isn't it? Okay. Knowledge that 10 millimeters is 1 centimeter. So you might have to, to bring units in line, or 100 centimeters is a meter, that kind of thing. You might have to use anything like that in that question, plus using density, plus using, an ability to work out surface area of basic shapes. Okay, these next few things here are what this video is about for the next sort of 10 minutes, okay? Circle theorems, we're talking about the AST, the alternate segment theorem, which is if a line comes in and goes like that, and then it makes that triangle inside the circle, that angle there is the same as that there. That triangle is obviously inside a circle. Similar shapes, higher level, is area scale factors and volume scale factors. Probability, again, these probably group. All these kind of can lead to a tree diagrams question, because you need to know probabilities add up to 1. You need to know about independent events, so things that don't affect each other, equally likely outcomes, etc., etc. All kind of tie in with there. The other thing we did today was a bit of dice and coin work, so knowing, you know, if I wanted 2 6s, if I rolled 2 dice and I wanted 2 6s, the probability of that happening is 1 over 36, that kind of thing. And then this, I don't know, you've already been asked it in paper 1. It's one of those more difficult ones, dependent events without replacement, where a ball is taken out and not replaced. So you might get another small one of those. Right, but this video is about what we said, like those last couple of questions. Okay, so we're going to scroll all the way through. I covered most of everything else today. Alternate segment theorem, rational and irrational numbers. Didn't really mention that today, okay? But if it is about cones or spheres, everything you need to know is in the formula sheet, okay? But, you know, use your brains as well. What have I got here? I've got half a sphere, but if I'm talking about the surface area, not only have I got half the surface area of a sphere, but I've also created, by cutting it in half, this circular face on top. So I'd need to add the area of that circle onto half of the sphere, right? But your formulas are all in the front for spheres and cones. This is what I'm talking about, factorize it, simplifying by factorizing, okay? Ask me if there's any problems with that. That's an alternative question for algebraic fractions where you would want to make the bottoms the same. So we'd make them both 10, so 10, 10, 10. And also think of this as 4 over 1, and I'd want to make that 10 as well, okay? So what have I times that by? 5 times all those by 5. I've times that by 2, times those by 2, and I've times the 1 there by 10, so I have to times the top by 10, and you create a linear equation. Get 20x minus 25 plus, which is in the middle there, 2 times 7x, 14x minus 20 equals 4 times 10, which is 40, okay? So 34x minus 45 equals 40. So 34x, and this is a linear, not quadratic, so it's letters one side, numbers the other. So x is 85 over 34, and unlike non-calculator, where I would probably tell you to leave that, dump that in your calculator. I'm pretty sure it's 2.5. You can check for me because I haven't got my calculator to go here. Right, so if we're going to get a factorising, that it could crop up like that, okay? Whereas a quadratic formula is much more likely. Look at the wording. It might not say using the quadratic formula, but it will say solve this equation, solve this quadratic equation. That was a nice clue. It even told you, solve this. And that is the big clue to use the quadratic formula. Give your answer to 2 decimal places. So you'll write x equals minus b plus or minus, etc., 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 where a in this question is the number before x squared. B, be super careful of b, that if it is negative, you make it negative when you substitute it in. So this would become minus, in brackets, minus 10 when I put b in there. Okay, and c is 3. Another example where we had to form the quadratic, and then part B was to solve the quadratic. So you do all the main work is down here, okay, and we're here. Okay, right. If we have 2 linked triangles, whatever is linking them, normally we have to find that to help us out. So here, the link between these 2 triangles is this side here, okay, and on this triangle I know a side and an angle. And on this triangle, I know a side, an angle, and a side, so I know more information. So I'm going to start with the triangle I know more information on. What I know here is this triplet, or as we now know it from congruence, we know a side angle, side, the triplet, side angle with the enclosed angle. Okay, if I wanted to work out this side using that triplet, I would be using the cosine rule, which is a squared equals b squared. Now in this setup, if that becomes little a, because that's the side I'm trying to find, the other 2 sides in any order can be b and c, but that angle there becomes big A, okay? So a squared equals 8.2 squared b squared plus c squared 7.6 squared minus 2 BC 8.2 7.6. I'm going to run out of room, but cos at the end, big A, which is 42. Okay. I'm not going to actually answer this here because I don't want to spend too much time, but stick that in your calculator in one foul swoop and get your answer to that, okay? But that's what A squared is. In order to find out what A is, we'd have to take the squared over, and we're going to square root whatever that came out to be after I substituted in those. So that's the cosine rule to find a side. The cosine rule to find a side. The other rule that we're dealing with in this question is the area rule, because it says right now we give the area of the quadrilateral, but you're not thinking of this as a quadrilateral, you're thinking of it as two triangles stuck together, okay? And you need the same information for the area formula as you do for the cosine rule. So here, this first triangle, the area is half AB sine C. So we're using the same triplet. But in this formula, and unfortunately, that becomes A, that becomes B, and this becomes big C instead. It's just some confusion, isn't it, for confusion's sake? But it's the same triplet, it's the same SAS, right? You're looking for boom, boom, boom to do the cosine rule or to do the area rule, yeah? Okay, so half A, B, sine C, and you can work out the area of that triangle. And then in this triangle, triangle ADC, this one here that I'm shading in, we can do the same thing, half A, B, which we will now know because we've worked it out there, sine C, because you'll now know enough info to use that triplet there. And then you can add your areas together. So that's that one, okay? An alternative, right? It takes a bit more work, this one again. Right, I wanted to do this one because they sometimes like asking the area question in reverse, particularly on these hard ones at the end, okay? As in, this is the area of the triangle, what is the missing length, etc. So it says the area of triangle ABD is 16.2, but normally to work out the area, we need the triplet. We'd need this, this, and this, okay? But the thing that's actually missing here is that's what I don't know, and that will help me going forward because that line there, that line from B to D, belongs on both triangles. So actually, I'm going to use that area to work out X, to work backwards, okay? Let's do that first, right? So half A, which is that one, B, which I don't know, sine C, which is the angle bit, 42, equals, and we know the answer. It's a lot easier to do this than you think. Whenever you know three other things over here, but there's one missing, okay, particularly if it's one of the sides, times everything that you do know, bar X. So if I grab a calculator really quickly here, see if we can get this calculator up here. All right, not the best, but half, I'm going to put in 1 divided by 2. There's better ways to do it on our calculator. Half times 7.3, because I don't like the bracket thing on here, okay? Times, and I think it was sine 42, but on here you do it the other way around. Please ignore the way I'm having to do this. No, you don't. Interesting. Oh, okay. Back we go. And we can actually, it is sine. Oh, that's quite nice. Sorry, I'm having a conversation with myself. So, pretty much that. So the only thing I haven't times is the x, which gives me, that's interesting. Half times 7.3 times sine 42. I don't think, oh, look at that. This is another thing. I'm glad we had this conversation here, right? This calculator on here is in rad mode R. You're going to check, and I'll mention this to you in the morning as well, that your calculator is in degree mode. Okay? Because it's not that in degree mode. There we are. That's what it is. I don't know if I need to do that again just to check. Oh, let's yeah. All right. Let's assume it's right. 2.44. Okay. So don't know if I trust it or whether I should do that again. Oh, we'll go with, we haven't got a lot of time, you can check it on your calculator, but I'll just keep going anyway. Right, so 2.44, and the only thing I didn't times there was the x, so that stays, equals 16.2. Okay, so x equals 16.2 divided by 2.44, whatever that is, 7 point something, right? Okay, if it was the angle that I didn't know, by the way, then yeah, you would still, just in case this is, right, you could still times those three together because you'd know that, okay? You could still divide by your answer over there, but it would be sine angle that you don't know, so you'd then have to do sine minus 1. If ever you're finding an angle, in trigonometry or sine and cosine rule, you're going to be using one of these, if ever you're finding an angle, okay? Now, we now know that this is, okay, I'm going to call it 7 for now. I'm not going to, no, I'm not. I've got to be more accurate than that. 16.2. 16.2 divided by my last answer is, oh, it's lucky I didn't. It's not even 7. So 6.6. 6.6. Okay, let's get back on. Okay, get rid of that. 6.6. Okay, now that we know that that is not 7 at all, but 6.6, right? On this triangle, we're trying to find BCD, which is this angle here. And if you look at this now, this is opposite pairs. We have a complete pair, the 28 with the 3.6, and an incomplete pair there, the 6.6, and the angle we don't know. So it's the sine rule, an incomplete pair. So sine, all right, we'll call it x for now, which I don't know it, the angle I don't know, divided by 6.6 equals sine 28 divided by 3.6. Take the 6.6 up there as a times, work that out, and then remember that's what sine x is. But like I just said, anytime we're finding an angle, it would be x equals, or theta if you prefer, sine minus 1 of that, and you can work that out for yourself. And finally, okay, the basics of this is about the hardest one I could find, right? And so I'm not going to spend long on it, but I want you to be aware of three things. A sector, put a number in there, let's go with 51, okay? So the area of the sector would be pi times the radius, which would be here, squared, times the fraction 51 out of 360. That would be the area of that. Whereas the length of this, the arc, would be pi times the diameter times 51 over 360. Okay, two quite common ones. What they've done in my picture here is they've done a sector cut away from a bigger sector. They've chopped that off to leave that. Another one that they quite like is a triangle cut away from a sector to work out the area of this. And we know that the area of the triangle would be half AB sine C, like we've just been doing in the questions before. Whereas the area of the sector we'd have to work out using pi r squared times whatever the angle is over 360 there. And then we could take the triangle away from the sector. This was quite a nasty one though, I thought, here, just to finish, okay? So, right, think about what I've done here is I'm chopping the inner circle out from the outer circle, okay? We are told that the length from O to P is 10, but the length from O to R, so just this bit here, same as O to S, is 6. So, what I would do to work out that area there, okay, actually, let's look at the question as well. The area, it tells us the area, my apologies. That's the area of this part here. However, how would I actually work out the area of that? Here's what I would do. I would work out the area of the big circle. Okay? I would then chop out the area of the littler circle inside it. Right? Put those in brackets. okay? All that can be worked out on your calculator. That would give me the area of the full ring that is here that I am colouring in. But the fraction I want, well, I don't know this angle. This is what I'm trying to find out, is theta over 360. But the answer, we are told, the area of this is 48.03. Okay. Work that out. I'm sure, okay, but please, again, just check. I'm sure I remember somebody telling me earlier it was this, right? Times theta over 360, and then it doesn't matter what order you do this, equals 48.03. The opposite of times in by 200.96 would be to divide that by that, and the opposite of dividing by 360 would be to times by 360, and you'd get the answer theta equals 84. And then a slightly easier, right? And if ever you get this, if you think, oh, I could have done B if only I knew how to do A, make it up. Just come up with an answer for A, make up an angle so that you can keep going with part B, okay? So it says using your answer to part A. So even if your answer is wrong to part A, crack on, make up an angle and let's get on with it. The perimeter of the shaded region. Well, the shaded region has 4 parts. This line, which has a length of 4. This line, which has a length of 4, 10, take away 6. This arc and this arc. Okay, so the bigger arc, right, think about it now, the diameter of the bigger arc, if the radius of the bigger arc is 10, then the diameter is 20. So the bigger arc is pi times 20 times 84, which we now know, over 360. The smaller arc is pi times 12, which is double 6, the diameter, times 84 over 360. Work out the length of that, work out the length of that, and then don't forget to add on those 2 4s to get the complete perimeter. So that, and the 2 4s. Okay, we can do a little bit more of that. If you've got any questions, let me know. I'm going to end there. Happy revision for the rest of the night, and see you all in the morning.